In this video, we're going to find the electric field due to an infinite sheet of charge. The way we begin is that we start with the electric field due to a uniformly charged disk, which I've done in a different video. So, if we have a charged disk with radius capital R, we know that the electric field at distance x from its center is given by the magnitude is 2k sigma pi onto 1 minus x over the square root of x squared plus r squared. Now, if we are going to find the electric field of a uniformly charged infinite sheet, all we have to do is go really close to this disk. And so essentially what it means is if we think about the disk, and if we go really close so that x is really small compared to r, that is essentially, it looks like an infinite sheet. So what we want to do is find the approximation of this electric field for x much less than r. So in the denominator up here, if x is much less than r, then we can say that x squared plus r squared is just approximately the same as r squared. And then we can also say that x divided by the root of x squared plus r squared is essentially the same as x over r, and if x is much less than r, this essentially goes to 0. And so the electric field due to an infinite sheet becomes just the term out front, 2k sigma pi, where sigma is the charge density of the sheet. Now, it wouldn't have any dimensions. You wouldn't use q over pi r squared like you would for the disk because it's an infinite sheet. It's simply the charge per unit area on the entire sheet. Now remember that k, Coulomb's constant, which is 9 times 10 to the 9 Newton meters squared per Coulomb squared, is also defined to be 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space, which is 8.85 times 10 to the negative 12 Coulomb squared per Newton meter squared. And you'll often see the formula for the infinite sheet written in terms of epsilon naught rather than k. And so substituting that in, we get 2 sigma pi divided by 4 pi epsilon naught. Pi's cancel, and we're left with sigma over 2 epsilon naught. And that is the formula that you use for the electric field due to an infinite sheet of charge. Now notice that that does not have any x or r in it. It means that for a sheet of charge, the electric field is constant throughout space on either side of the sheet. And so on that side and on this side, and there are no edge effects. We don't have to make the electric field lines curvy on the edges because it's an infinite sheet. And so this is E, and that would be sigma over 2 epsilon naught, and E over here would also be sigma over 2 epsilon naught. So basically it's the same value everywhere, emanating perpendicular to the plane of the sheet out in both directions. Now there is a question on one of your Mastering Physics assignments where you have two infinite sheets of charge separated by some distance. It doesn't matter what the distance between them is because the field is the same throughout the whole distance between them and on either side. So if this has charge density sigma 1 and this has charge density sigma 2, and we want to know what the field is in the three regions here, left of them, between them, and to the right of them, what you do is you draw the electric field due to sigma 1 to the right. Now it goes, sigma 2 doesn't affect the electric field due to sigma 1. It goes right through the sheet sigma 2. And so this is all E1. In between, it's this way, E1. And that E1 would be sigma 1 over 2 epsilon naught. Now sigma 2 has its own electric field, so let's do that one in red. So this sigma 2 would have everywhere on the right, the electric field E2 would be going to the right like this. So that's E2. In between, it would be going to the right, E2. But over here, it would be going left, away from the positive. So that would be E2. Now, if you want the net field in these three regions, left of both plates, between the plates, and right of both plates, you simply add these up. So here, the net field, E net, would be E1 plus E2. Magnitude. So that's the magnitude of E net. And these would be magnitudes, because they point in the same direction. But between them here, the net magnitude would be right minus left. So it would be E2 magnitude minus E1, because they point in opposite directions. And over here on the right-hand side, the magnitude of E net would also be the sum E1 plus E2, because they point in the same directions. Okay, so that's how you handle infinite sheets of charge.